Hi everyone, this is Nicole Dyer. Welcome to the Research Like a Pro with DNA question and answer series. Today I'm sharing part 2 of the question, how can I use Ancestry Custom Clusters to find matches relevant to my research question? And in this part we'll talk about analyzing the results of your custom clusters. First, let's review the original question. It said, how can I use Ancestry Custom Clusters to find matches relevant to my research question? And how do I choose a match of interest and sidekick matches? Let's go over Ancestry DNA matches by cluster. First of all, you have to have the Pro Tool subscription at Ancestry so that you can use matches by cluster. And the first option is the standard clusters, and this is from 65 to 1300 centimorgans. So all of the matches that you have within that range would be eligible for clustering in the standard clusters. And it focuses on matches that share 20 centimorgans or more with each other. So for standard clusters, the purpose of this is to cluster all your close matches and helps you find those unknown parent or unknown grandparents if you have any. It can also help you just get started with grouping your matches to know which line to focus on. One thing that's different about the standard clusters versus the custom clusters is that in standard clusters, a match can only be in one cluster. And if they overlap with another person in a different cluster, you will see a gray square in between those two clusters. So those gray squares that you see on the screen are showing overlap between the orange and the pink cluster. With custom clusters, you choose a match of interest, and then the clusters are going to be focused on that line of the family. You can also select up to 4 sidekick matches that are shared matches of the match of interest. Then you set a custom centimorgan range for which matches to include. And so in custom clusters, a match can be in multiple clusters, and you'll often see matches repeated in different clusters. And this can help you use those larger matches that are repeated kind of as waypoints to help you see which line of the family this cluster is likely on. A little more about custom match clusters from the Ancestry support article on this. So the purpose of this is to help you discover matches who share DNA with a match of your choice. And you can add 4 related matches to narrow the results further, and these must be shared matches with the primary match of interest. Custom clusters can go low, like as low as 20 centimorgans, or as high as 1300 centimorgans. And if you're not sure what range, then you can look at this chart from the support article and think about what level of cousins you're hoping to find based on your research question. So if your mystery ancestor is your great-grandparent, then your cousin level would be second cousins. And so you're looking for second cousins in your DNA matches. And the centimorgan range that you'll want is 90 to 340 centimorgans. Then for second great-grandparents, you are looking for third cousins, which are in the range of 40 to 120 centimorgans. For third great-grandparents, you're looking for fourth cousins, so you're going to want to go down to 20 to 60 centimorgans. There are some limits with how many matches can be displayed in the matches by cluster view in the cluster chart. And in this help article, it talks about how matches by cluster can display up to 100 matches at a time. And if you have more than 100 matches across all clusters, the chart view won't appear automatically and you have to see the clusters individually or filter by the parental side, so maternal or paternal. And this is specifically talking about the standard clusters. If you're looking at the custom clusters, it might be a little different. In fact, usually I don't see the chart view at the top, even when I have less than 100 matches in the matches by cluster. So it just kind of depends, but what you can see are each of the clusters individually, which is still helpful. For my case study today, I'm going to be talking about my ancestor, George Welch, who was a farmer born in Pendleton District, South Carolina in 1802. His parents are unknown, and so I want to use Ancestry Custom Clusters to help me find any new leads I can work on here. So the test taker that I'm going to be using for this at Ancestry Custom Clusters is Vera, and George Welch is her second great-grandfather. Now it's also important to understand Vera's entire pedigree because we're going to be looking for a lot of common ancestral couples, and some of the matches are probably not going to be descended from George Welch. And this is a common mistake that we can make, which is focusing only on our ancestor of interest, especially if we're looking at a cousin's DNA results, which I'm doing. And so Vera is not a close cousin. She's a third or fourth cousin, and she's shared her results with me at Ancestry. And so when I look at her results, I want to be aware of her entire pedigree so that I don't get confused about who the common ancestors are. So I worked on building her tree, and I'm trying to be aware of all of her ancestral couples that might be the common ancestors with different clusters in her cluster chart. So Ancestry suggests starting with a match of interest, and it gives you some reasons for why you would start with a match of interest. And it talks about picking a second or third cousin, and if you have close cousin matches, choose a cousin related to you through your brick wall ancestor to find other matches connected to that ancestor. So choosing a closer cousin like this will help you get more clusters and more shared matches included in those clusters. You can prioritize matches with distinctive last names, locations, or trees that don't overlap with your known relatives. Follow your curiosity, start with brick walls, or check your shared matches. So to choose a match of interest, I like the idea of choosing someone between a second and third cousin, so about 90 to 300 centimorgans. And I think the bigger the match, the more shared matches they have, so that's probably a good idea to include someone who shares more. And I want to pick someone who's already known to be related through the mystery ancestor, my research subject, and for me that's George Welch. And so doing this is supposedly going to help me identify matches related on that line of the family. Well, what should you do if you have a lot of second or third cousins that you've identified? And I do have a few different options here. And so in Angie Bush's article about custom clusters, she talks about choosing sidekick matches. So maybe you do have more than one second or third cousin that descends from that mystery ancestor. So then you can choose more people for your sidekick matches. And the sidekick matches are optional, so you don't have to pick any at all. Your centimorgan range maybe is lower than one of the people that you'd like to include. So then in that case, you could add a sidekick that's outside of your centimorgan range. So maybe you're only going from 20 to 60 centimorgans, but you have a match, a sidekick potential match that shares 90. So you can include them as a sidekick. This will help you cast a wider net. And you could potentially use a match sharing less than 20 centimorgans if that's outside your range. But I don't know if that's the best idea because it says in the instructions that it doesn't include people who share less than 20 centimorgans with each other, so that might not be a good idea. All right, so I am going to use Jill, and she's going to be my match of interest. I saw that her tree goes back to James Monroe Welch and even further back to George Welch, who is my research subject and my mystery ancestor whose parents are unknown. So I'm hoping that because Jill shares 96 centimorgans with Vera that she'll be a good starting match. So looking at Jill's descent from George Welch, I noticed that it was really far back where George Welch was and looked odd. So I charted this out and it showed that Jill and Vera would be third cousins 4 times removed, and that seemed wrong. So I went back and looked at the tree again, and I noticed that there were a couple extra ancestors in here that could be deleted that are incorrect. David Welch, who died in 1909, is the son of George Welch and Lucinda, so these extra 2 ancestors were just added by mistake, probably. So now that I fixed the descent line, Vera and Jill are second cousins 2 times removed. So for my first attempt at making custom clusters, I decided to just generate the clusters using Jill without any sidekicks, using a centimorgan range of 20 to 90 centimorgans. After counting up all the matches, which they overlapped quite a bit, so it was harder than you might think to count these up. There were 106 unique test takers across 7 clusters, and 27 of those matches were in 2 or more clusters. 79 of those matches were in just one cluster only. So that was interesting, and looking at all these clusters, I thought that was a pretty good result. I looked at the second cluster and tried to figure out who all the people were in that cluster, and I realized they all descend from David Welch's son, James Monroe Welch. And this is Jill's second great-grandfather. And I noticed that everyone else's common ancestor, it was their first great-grandfather. So Jill was just one generation removed further away. And I saw that these are all mostly second cousins, and it's a really tight cluster where everyone's matching each other, and it seems that that's probably because they're mostly second cousins, and at that level, most second cousins are going to share with all their other second cousins. So that's really interesting to see that being the case here in this really tight cluster. There's no cells here where they're blank or tan, which would indicate that they don't match or don't share at least 20 centimorgans or above. Okay, so I thought I would try again, this time adding some sidekicks to see if it changes the custom clusters at all, and just to experiment with it. So I had the question, if I include a sidekick match who shared less than 20 centimorgans, would that be an effective way to incorporate a sidekick, or would it be pointless? And so I chose Perry, who's descending from George Welch through a different child line, and I put the centimorgan range at 20 to 90 centimorgans, and the result was the exact same. The clusters did not change at all from the first attempt, and I think it's because Perry just didn't share enough DNA. He only shared 8 centimorgans with Vera, and so he probably didn't share enough DNA with the other shared matches either, so it didn't really do anything. So that was a failed attempt. So I recommend sticking with sidekicks that are 20 centimorgans or over, or maybe ones that are really close, like 19, but probably ones that are over 20 centimorgans would be the best. So to try this attempt again, attempt 2B, I added another sidekick, Anne, who is a descendant of George Welch through a different line, and she shares 17 centimorgans, so I wondered if that would affect the clusters and how it worked, and it actually did. So maybe sharing 15 centimorgans or above is a good kind of cutoff for your sidekick matches. Going too low, like 8, didn't really do anything. And it probably just depends on your match list, but I thought that was interesting. So Anne must have had different shared matches that were then included, and so it helped with casting a wider net, increasing the number of matches and shared matches that were included in the clusters. So we got different clusters. For my next attempt at custom clusters, I kept Jill as the match of interest, and for the sidekicks, I found 3 other descendants of David Welch that shared more DNA. So I was kind of looking for casting a really wide net by getting people on this line of the family who share more than even 96. So I went with Donna, who shares 299 centimorgans, and she descends from David Welch, and Kurt, who shares 168 centimorgans, descending from David Welch through a different child, and then Isaiah, sharing 141 centimorgans, who descends from the same child as Kurt and Jill. And the centimorgan range I picked was 35 to 60, and I picked that just to try a different range to see if it affected the number of clusters and the number of matches included and kind of how it looked. Okay, so I was pretty excited with the result here. I've added some screenshots of what the clusters actually looked like next to the number of matches, and to kind of show how many people were in each one at a glance and what it looked like. So I'm going to analyze the results of my third attempt at custom clusters and show who the common ancestors were for all of these clusters, so that it might help you see some of the value that can come from doing the custom clusters and what we can learn from them. So first of all, I wondered, out of Jill's 266 shared matches that she has with Vera, how many of those are actually in the range that I picked for this cluster diagram? And so when I looked at Jill's shared matches page and filtered it to be between 35 and 60 centimorgans, there were only 32 matches in that range. But as I tallied up the number of unique matches in this cluster diagram, there were 91 matches. And so a lot of those sidekick matches increased the number of matches that were included in the cluster diagram. So adding those different sidekick matches was really important. And it helped get better coverage. So the first cluster had 9 people, and cluster 2 had the same 9 people but added 2 more. So that's why there were 11. And then cluster 3 added 3 new people to get up to 14 matches, and cluster 4 only added 1 new person. So all of these clusters are kind of building on each other, and they're not each different clusters. They're the same cluster with 1 or 2 new people added. So then, for example, cluster 5 had 35 more people added, and you can see in the screenshot of this that there, within cluster 5, there are a couple smaller clusters and then even some really tiny clusters in the bottom right. And I'll show you close-up images of these in a minute. Well, cluster 6 added 41 new people and also broke down into smaller clusters within a cluster. Now let's start with cluster number 1 and see who the common ancestor is. There were 9 matches in cluster 1, and although the range was supposed to be 35 to 60, the sidekick matches that shared more than that were included in the clusters, so that's why it went all the way up to 168. So it included Jill, the match of interest, and only 2 of the sidekicks, Isaiah and Kurt. And everyone matched everyone else. And as I looked at their trees, I found that the common ancestral couple was James Monroe Welch and Emma Page. And that's interesting because that's not Vera's ancestor, that's Vera's ancestor's brother. And so this cluster kind of picked up on the fact that there were a bunch of people descending from James Monroe Welch and put them all together in this cluster. And I thought that was brilliant that it could pick up on that. And I think it's because it's using the amount of DNA shared between each other. And we can see that now in the Pro Tools shared matches. So the fact that Isaiah and Jared and Kurt and John and Byron and Connor all shared a lot with each other helped group them into this cluster. So the common ancestor is Welch Page. Now going to the next cluster, number 2, there were 11 matches. So it added Donna, one of our sidekick matches, to the existing people in cluster 1. And the common ancestor now is Vera's common ancestor with all these matches, David Welch and Minerva Hancock. And the 2 matches that were added are here on the left of the diagram, descendants of Selma Page, and they are also descendants of Margaret Rosetta Welch, which is Vera's grandmother. And so now we have all of the people here descending from David Welch. So common ancestor is David Welch and his wife Minerva Hancock. But wait, there's another common ancestral couple, and it took me a while to figure this out, but John Page and Mary V. Ellis from Vera's pedigree chart are also common ancestors because Margaret Rosetta Welch and James Monroe Welch both married a Page sibling. So we now have double cousins in this cluster, which complicates things quite a bit. So when I figured this out, I remade my lucid chart diagram to highlight the fact that they're all descending from these ancestral couples and making them double cousins. So at the top of the chart, you can see David Welch and Minerva Jane Hancock are the parents of James Monroe Welch. Then I put David Welch and Minerva Jane Hancock on the right of the diagram top as well because they're also the parents of Margaret Rosetta Welch, making James Welch and Margaret Welch siblings. These two siblings married other two siblings from the Page family. So John Page and Mary Virginia Ellis had two children, Emma Page and Arthur Page, who married into the Welch family. So because of this, all of the descendants who are matches with Vera, who's a descendant of Arthur and Margaret Welch, those are double cousins with her because they all have the two ancestral couples. So that's going to complicate the cluster chart analysis a little bit. But it's important to know that and to figure that out. Now, cluster 3 has 14 matches, and it includes all of the people in the second cluster plus 3 more matches. And these matches are on the right of the descendancy diagram with pink, and they are Jack, Edmund, and Sarah. And these 3 matches descend from Melissa Welch, which is actually my ancestor, and they are descendant of George Welch. So Melissa is the daughter of George. So now we have the common ancestral couple of George Welch and Lucinda Keaton. What's interesting is that because cluster number 2 actually had 2 ancestral couples, some of the people in that cluster are not overlapping with the George Welch descendants through Melissa Welch. And so you can see a little bit of separation in this cluster, showing kind of 2 different clusters kind of forming, one at the top left, one at the bottom right. And so those 3 new matches that were added in, some of them match and overlap with the other cluster and some of them don't. So we have kind of these 2 sections, the Welch-Hancock and Page-Ellis double cousin cluster, and then the Welch-Keaton cluster at the bottom right. Now let's analyze cluster number 4, which is the purple cluster. And there are 15 matches here, and it includes all of the same matches plus 1 new match. So it's the same as cluster 3, but 1 new match. And so we still have that double cousin cluster of the Welch-Hancock Page-Ellis cluster. And then we also have the Welch-Keaton cluster at the bottom with those 3 Welch-Keaton descendants. And then we have the new match, which is right here. And the new match kind of overlaps with the Welch-Hancock and the Page-Ellis cluster. And looking at the family tree, there wasn't any obvious surname clue about any of these ancestors being part of that cluster. So I looked at the shared matches for this new match and sorted it by the matches relationship close to distant. So you can actually click on this little drop down to sort, and instead of sorting by your relationship, you have to switch it over to the matches relationship. And once you do that, then you'll see all the matches that are closest to that person, so that shared match. And that can really help you figure out who they are, especially if their tree isn't that helpful or if they have no tree. And what I noticed when I opened up all of the trees of the closest matches is that they were all Hancock matches. Most of them, some of them even had the surname Hancock, and several of them had Hancocks in their trees. So this one match that was overlapping with the Welch-Hancock and Page-Ellis cluster, but not the Welch-Keaton cluster, seems to be a Hancock descendant. So looking into the tree further, I found that Eugene Jones in the tree of this match had a mother named Julie Etha Hancock, born in 1893. And when I looked into her tree, I found that she was in the exact same location that Minerva Hancock lived in, and her parents were uncertain, kind of unknown. When I was building Vera's tree, I saw that and noticed that there were potential parents for Minerva Hancock in the census in 1860, so might be Richard Hancock and his wife Emily, but there's no direct evidence yet. So there were multiple most recent common ancestors within this cluster. So it's an interesting part of the custom clusters that you might see this kind of subclustering that goes on. When there's overlap between one cluster and another cluster, they just put them all into a cluster together so that you can then see the overlap. Instead of losing that valuable data, it preserves the overlapping, but just kind of keeps the cluster from the previous cluster and adds one or two matches so that you can see how they relate. So here's what the Hancock cluster looked like when I built it out, and using the shared matches that I found from this individual, I was able to find several more descendants of the same Hancock, mostly from Eli Hancock, who was born in 1857 in Texas near where Minerva lived, and it could be a brother to her. And some of these matches shared within the range that I selected for the cluster diagram, but most of them were below that. So there were only, 2 or 3 that were above the range that I had selected. So you can use the clusters as a starting point for finding a relevant person, but then it really helps to go to their shared matches and look at all of their shared matches, sort their matches by how they relate to the match and not to the test taker, and then look for common names and see what you can find. So now this is exciting to have a new cluster of matches that all descend from Eli Hancock and another James Wesley Hancock to help figure out Minerva Hancock's parents. So looking at Vera's pedigree again, we can see Minerva Jane Hancock there with the potential parents that I had put for her, Richard Hancock and Emily Martin. And now I can verify that and try to find connections in the documentary research to see if that cluster of Hancock matches is giving evidence for this parent-child relationship between Minerva Hancock and Richard and Emily. The next two clusters, 5 and 6, had a lot of overlap, and cluster 5 doesn't really have any unique matches. Everyone is in the previous clusters or in cluster 6 except for one person. Cluster 6 does have some unique matches that aren't in any of the other clusters. And what's interesting is that the fact that there are these double cousins that were used as the matches of interest and the sidekicks, I think is what is causing all of this overlap. So while at first it was confusing, when I figured out that there was that double cousin issue that was kind of polluting the information, it made it easier to understand why there was so much overlap. So let's look at cluster 5. So cluster 5 has 44 matches, and it includes the match of interest Jill and the 3 sidekick matches Isaiah, Kurt, and Donna, which all of them are double cousins with Vera. And so we're going to see both sides of the family here. We're not just going to see the Welch side like I had hoped. We're going to see the Ellis side as well. And so with this cluster, it's the same cluster as number 2 plus 29 different matches. And these new matches are in this cluster A that I've labeled. And so this is like a subcluster. And when I did the pedigree triangulation, I didn't find a common ancestor, but I did find some people within this cluster who went back to an ancestral couple with the surnames Burton and Smiley. Then I found a couple other who had the Sampson-Creasy ancestral couple, but none of them were back far enough where I could find a common ancestor for most of the people. So while this is a really tight cluster, sometimes that indicates a close relationship between the matches, but these ones only shared about 30 like 35 centimorgans. It was all in the small range, between like 35 and 38 centimorgans. So what I guessed is that this is a population segment or just a segment that was passed down by a founding ancestor in the southern states. Their lines all seem to go back to Virginia, so I'm guessing they all have a common ancestor back in the early colonial times. So it was pretty difficult to find any overlapping ancestors for everyone. Then there was this match right here, and as I looked at this match's tree, it looked like their tree did go back to an interesting ancestral couple. So that was really interesting. It had the surname Welch. It was Margaret Welch and James Mauldin. And Mauldin is a name that's really interesting and useful because it's a fan club name for the Welch and the Keaton family. Then this next cluster, cluster B, was that double cousin cluster, Welch, Hancock, and Page Ellis. And then down here, cluster C had two more descendants of David Welch and Minerva Hancock, so they were just sharing less DNA. So there were a lot of different most recent common ancestral couples, and so there were the Burton Smiley, Sampson Creasy, the Chastain surname. There was also that Welch surname that came out in that one match that I circled. But all of these different clusters within the cluster had kind of different ancestral couples. And so it was interesting to see that. And we had these mini clusters at the bottom. And I didn't figure out who the common ancestors were for anyone in D through F. But it was interesting to see that some of the common ancestral couples were probably further back on the Welch, Hancock, Page, or Ellis lines. And I think what's going on with the unknown cluster is that it's somewhere back further on the Welch, Hancock, Page, or Ellis lines, but I just don't know which because of the double cousins. All right, so cluster 6 has a lot of overlap with cluster 5, so it's the same as cluster 5 plus 41 more matches that are in this A subcluster. And as I did the pedigree analysis of these matches, I found a common ancestral couple pretty quickly, John D. Ellis and Mary Belle Adair. And so I'll go ahead and I also noticed that this B cluster here is the double cousin cluster of Welch, Hancock, and Page Ellis. And cluster A, I think, is just going further back on the Ellis line. So Ellis Adair, and a lot of those matches who descend from John Ellis and Mary Adair also match with the descendants of Page and Ellis that are in cluster B. And then I found this cluster C here that was again in cluster 5. I couldn't identify a common ancestor, but it's probably further back, that colonial segment that goes further back. So looking at Vera's pedigree again, we can see that we found clusters for Ellis and Adair. We've found a Hancock cluster. We found a further back cluster on one of these lines that we couldn't identify. And so here's John D. Ellis and Mary Belle Adair, all the matches that I was able to find for this family in that big cluster that I showed you in cluster 6. So that was exciting to be able to see a big group like this. And at first I was a little bit confused about who these people were because I wasn't that familiar with Vera's pedigree to know that these were her ancestors. But once I looked at her pedigree again and saw that, then I was able to make sense of what was going on with these clusters of the double cousins and figure it all out. So after a lot of analysis, I found that this cluster chart was showing a lot of different lines on the paternal side of Vera's family. So after figuring out that I had used double cousins as my sidekick matches and my match of interest, I decided to try again to make custom clusters just to focus on George Welch and to get a match of interest that was not a double cousin with the test taker. So I found Jake, who is descended from George's son James Welch, and he shares 114 centimorgans with Vera. And so that was the biggest match I could find descending from a different child of George Welch. And so I put him in as the match of interest, and then I chose sidekick matches that also descend from George Welch through different children. So I had Melissa, Susan, Nicholas, and Martha Lucinda, all children of George Welch who had a descendant who were in the shared matches with Jake. And so I picked those as sidekick matches, and I picked the centimorgan range as 20 to 110 centimorgans. And I was surprised that there were not any big clusters like I had seen in the previous cluster result with my double cousin clusters, which may be the reason that there were so many. So I did find that the limitation of only going down to 20 centimorgans was kind of holding this analysis back because a lot of the matches that are relevant to this case are going to be smaller. So as I looked at these clusters, it was a lot of people I already knew and not really anything new and exciting. And that's because I've already done a lot of analysis on George Welch and his descendants in Vera's matches. So if you haven't done that already, then this will be really helpful for you. And I still need to go through and look at every single person and see what I can find. But I didn't see anything in the clusters right away that was anything new or exciting. Probably the biggest exciting find here was in that cluster 5 where I saw the Margaret Welch and James Mauldin match. That one was exciting. So that's my new lead that I'm going to work on, which is seeing if I can figure out if there's a connection between Margaret Welch and George Welch. And I think right now that they could be siblings to each other. And it was exciting to find that. I hadn't seen that before. And now that I've done a little more research on the Mauldin family, I recognize that name as being one of the really close associates of the Keaton and Welch family in Pendleton District, South Carolina. One of the Keaton aunts married into the Mauldin family, and one of Lucinda Keaton's sisters married into the Reeves family, whose mother was a Mauldin. So there's a lot of connection going on there. And none of these test takers are directly descended from those people that intermarried. So there's got to be another connection there. So it'll be fun to look into that. The takeaways from this analysis are to start with a well-chosen match of interest. So a second or third cousin who connects to your research question gives the algorithm the best foundation to work with. And I found that that worked really well for me when I was creating my custom clusters. Even though the match I chose was a double cousin, it was still really helpful in creating clusters that I was able to use to find the Hancock cluster and the Ellis cluster. So it was exciting to have those new matches pop out. Sidekick matches help focus your clusters, and adding related matches who descend from different children of the ancestor narrows the results and highlights distinct family lines. I really liked experimenting with different centimorgan ranges and sidekick combinations. I only showed you a few of the experiments that I did. I know it says that it takes 30 minutes to generate a cluster, but I've found it only takes a minute or two with these experiments that I'm doing with changing the different ranges of centimorgans, changing the different sidekicks, and trying a lot of different combinations. So it really is easy to create different clusters. And as I find matches that are relevant and helpful in the clusters, I keep track of them all in my research log in Airtable. So those do expire after a while, so be sure that you keep track of the important information from them. I did find that tight clusters could indicate two things. The tight clusters could point to specific ancestors, so like those second cousins who all matched one another so perfectly, or a population segment where everyone shared like a 35 centimorgan segment going back to colonial times, and it couldn't find a common ancestor. Then overlapping clusters can indicate closer family connections. So you might have second or third cousins that overlap with a cluster that's further back, and that can tell you which line that cluster is on in the family. And probably the biggest takeaway is to use clusters alongside traditional tree research, because cluster results are most powerful when you can pair them with family trees and figure out common surnames, common locations, and common ancestors. And so with the tight clusters or the loose clusters, what I've noticed is that the further back you go in the tree and try to get matches that share less DNA into clusters, you're going to see more loose or sparsely connected clusters where not everyone is matching everyone else in the cluster. And that's helpful too, because it gives you the clue that they're from a more distant common ancestor and not necessarily just a bunch of people that share one common population segment. So it's probably better to see a little bit of that sparseness there, indicating that they all descended from a common ancestor, but they got different segments, and so they don't all share with each other. They share sporadically, with some with each other and some not with each other. And so it's fun to see those clusters come together for those more distant ancestors, like we saw with the Ellis cluster and the Hancock cluster, where not everyone shares with everyone else, but there's a definite pattern that they're all descending from the same ancestral couple, even though they don't all match each other. And that's because they're only sharing 20 to 30 or 40 centimorgans. So hopefully that was helpful to think about how the Ancestry Custom Clusters can be used and how they can be analyzed and what we can do with them after we've generated them. So good luck as you try doing Ancestry Custom Clusters, and hopefully you can try a lot of experiments and find a cluster analysis that works for you to give you more relevant matches for your research question. All right, thanks for watching and good luck.